looking at a single research question in the same data set, and we're going to do, first we'll do the data set using discriminant analysis, and then we'll follow up by running it with multinomial so you can actually see the difference. So our research question is, are age, educational attainment, last prenatal visit, and ethnicity factors that predict if a mother will complete a 3-shot newborn vaccination series? So our dependent variable, we look at vaccination shots, and we actually have 4 groups. The first being no vaccination shots, and then we have first vaccination shot complete, then we have second vaccination shot complete, and then our 4th group is fully vaccinated. We look at our independent variables, first being age, which is a scale, our second being educational attainment in years, which is also a scale. Our 3rd variable is month of last prenatal visit, which is also a scale. And then our 4th independent variable, which is ethnicity, which is nomial, which is not used for discriminant analysis. And for ethnicity, we've got Pacific Islander, Asian, Native American, Native Alaskan, Black, and white. To run discriminant analysis, we get into our SPSS. We launch our SPSS. We go to Analyze. We use the drop-down menu. We go to Classify. We use the sidebar menu to go to Discriminant. We get the new window that pops up in the middle of the screen. And for our grouping variables, we move across vaccine shots. And then for our independent variables, which are all scales, it should be age, education, prenatal visit. I meant to take out ethnicity because we left ethnicity over in the variables box. We're just using the 3 scales. Now, when we, this is one thing important, is that we have to define the range actually for our grouping variable, which is our dependent variable. So we click on the Define Range button. And here we're going to put in 0 is our minimum, and our maximum is 3. That's actually all of our grouping variables. If you had a dependent variable that had, say, 9 different levels, and you were only interested in, say, 4 out of the 9 or 3 out of the 9, this is where you would actually select those 4 or 3. And we'll just go ahead and click Continue. And then when we get to, and then we're just going to hit the OK button to run it. At this point, I just want to make note that discriminant analysis in SPSS has many options, and what I'm doing here is just running essentially the bare minimum. As you investigate more into discriminant analysis, you realize there are many options, and you may need some of those output that SPSS will put out to answer your research questions. And so, but since there's so much complexity to it, I'm going to just keep it pretty simple this morning. So when we run, we click OK, and then we start to get our output. The first thing that we'll see here is it's a summary of the canonical discriminant functions, the eigenvalues. And first off, the function, this indicates the first or second canonical linear discriminant function. The number of the function is equal to the number of discriminating variables. If there are more groups and variables, or one less than the number of variables in the group variable. The eigenvalue, which is the next column, these are the eigenvalues of the matrix product of the inverse of the within group sums of squares and cross product matrix, and the between group sums of squares and cross product matrix. I know it's quite confusing, but this is really what the eigenvalues mean. The eigenvalues are related to the canonical correlations and describe how much of the discriminating ability a function actually possesses. The magnitude of the eigenvalues are indicative of the function's discriminating ability. So in essence, the larger the eigenvalue, the better the function is. We have percentage of variance. This is a proportion of the discriminating ability of the 3 continuous variables found in a given function. The cumulative percentage, this is the cumulative proportion of the discriminating ability. For any analysis, the proportions of discriminating ability will sum up to 1. And we've got the last column is the canonical correlation. These are the canonical correlations of our predictor variables, age, education, and prenatal, and the grouping variables in vaccination shots. The next box that SPSS puts out is the test of, it's really the Wilks-Lambda and the test of functions. Now, the test of functions, these are the functions included in a given test with the null hypothesis that the canonical correlations associated with the functions are all equal to 0. Right? In this example, we've got 3 functions. Thus, the first test presented in this table tests both canonical correlations 1 through 2, and the second tests both the canonical correlations 2 through 3, and the third one presented is just the third canonical correlation alone. The next column is the Wilks lambda, and this is one of the multivariate statistics calculated by SPSS. It is the product of the values of 1 minus the canonical correlation squared, actually. Then we have our chi-square. This statistic tests the canonical correlation of the given function that is not equal to 0. And then, of course, we've got the degrees of freedom. And our last column is the sig, which is the p-value, which is associated with the chi-square statistic for a given test. The null hypothesis is that the given function's canonical correlations and all smaller canonical correlations are equal to 0 is evaluated with regard to this p-value. So this is where we can actually see that our test of functions 1 through 3 is actually significant, and 2 through 3 is actually significant, but the third function is not significant. And here we have the standardized canonical discriminant function coefficients, and these coefficients can be used to calculate the discriminant score for any given case. The score is calculated in the same manner as a predicted value from a linear regression using the standardized coefficients and the standardized variables. One of the options within SPSS is to actually have SPSS calculate this out for you, where SPSS will actually create a table of each of your individual participants and show you where they actually grouped in terms of your data and where they should have grouped, or the way that the mathematical calculation SPSS would have grouped them. But those tables with 400 participants becomes quite lengthy, but it does have value in certain research questions. So next we have the structure matrix. Excuse me. This is the canonical structure, also known as the canonical loading or discriminant loading of the discriminant functions. It represents the correlations between the observed variables, our 3 continuous discriminating variables, and the dimensions created with the unobserved discriminant functions, which are known as dimensions. For those of you who are not familiar with canonical discriminant functions, the term canonical relates back to when they used to use cannons, essentially, to shoot cannonballs. The mathematics behind this is very similar. You have multiple linear lines of mathematical equations, and those are the canonical discriminant functions. So within SPSS, it looks to see how predictable or how much value in prediction those mathematical lines actually have. So here we have the functions of the group centroids. These are the means of the discriminant function scores by group for each function calculated. If we calculate the scores of the first function for each case in our data set, and then look at the means of the scores by group, we'd find that the no vaccine shots group has a mean of negative 1.775. We look at our first vaccine shot completed, that had a group mean of negative 0.463. Our second vaccine shot completed had a mean of 0.572. And those that were fully vaccinated had a mean of 1.632.